Good afternoon from the Johnson Space Center. I'm Dan Hewitt, and welcome to today's EVA briefing. We're here to learn about two spacewalks that are on the horizon for the Expedition 50 crew, making some important upgrades to the station's electrical power system. Here to tell us more today, I'm joined by my panelists to my left, starting off with Kenny Todd, the Operations Integration Manager for the International Space Station program. Just next to him are two lead flight directors, starting off with Judd Freeling, will be the lead for the spacewalk this Friday, US EVA number 38. Next to him, Gary Horlocker, who will be the flight director for EVA 39 next Friday. And on the end, to walk us through the fine details of the spacewalks is Keith Johnson, the lead spacewalk officer. As usual, we'll hear from each of our briefers today and then open things up for questions here in the room, on the phone bridge, and via social media. So with that, let's go ahead and kick it off. Kenny, take it away.
Thanks, Dan, and certainly Happy New Year to you all. Things are going very well on board the International Space Station. We're currently in the middle of what we refer to as Increment 50. Had a very busy December time frame that really started with the launch and the birthing of the HTV cargo module. The crew jumped into that right away and has done a lot of cargo ops. Also, there's a lot of science on board that particular vehicle, and so a lot of good science getting done during the month of December. The crew, Shane and Peggy and Thomas on the U.S. operational segment, and Sergey, Andre, and Oleg on the Russian segment have been doing a fantastic job. Got a little bit of downtime, but not a whole lot before moving into the preparations for these spacewalks they're going to happen over the next 7 or 8 days. The ground teams on the back end of December were also very busy. One of our primary missions for this HTV flight was to install the lithium-ion batteries, and last week our robotics teams, the ground teams, the operations, the engineering and safety teams all did great work over the last week and a half, moving these batteries and getting them installed where they need to be in order for us to go do these EVAs. I can't say enough about the work that team's done over the last week and a half. While a lot of folks were off celebrating the holidays, they were here getting it done and getting us in a good position to be ready to do these spacewalks. So the guys did a great job. Once we get this EVA done here on Friday, they'll be right back at it again, moving batteries, getting them positioned where they need to be on the other channel that we're going to go out onto next week. So, as far as looking forward, here in January, it's going to be a very busy next few months. Obviously, the first couple of weeks, we're going to be talking a lot about spacewalks and robotics here in the program. Towards the end of the month, we're going to be getting into more of a visiting vehicle flow. The HTV cargo ship, we're planning right now to turn it loose around the 27th of January, if everything holds to schedule. Shortly after that, it's sounding like probably January 31st, we'll have a progress ship departing from the DC Nader port. That vehicle is 64P. And then we'll turn our attention probably around the second or about the second week of February. We'll start planning for a SpaceX Dragon arrival. We've been working with that team as they've continued to recover from the issue that they had back in September, and currently we're all planning to a date of launching on the 8th of February, berthing on the 11th. So that's our current plan today, and all the different teams are working to that. So as far as that particular mission, the SpaceX mission, we'll plan for about 30 days. Got a lot of science on that particular flight, a lot of time-constrained science, so we are going to be doing a lot of work in a very short period of time when Dragon's on board. In addition to that, we need to get the port cleared, because in the March time frame we'll be ready to welcome a Cygnus module to the the station as well. So we're very excited about the next couple, 2 or 3 months here relative to the USOS visiting vehicle traffic. As far as the Russian segment, as most of you know, our Russian colleagues are continuing to work their plans for recovery from the issue that they had with 65P. We're still working to finalize dates for their next set of flights that involve a Progress, which is 66P, and then the next crewed Soyuz vehicle, which is 50S. So we're still working with them to finalize those dates. But back to where we are today, a lot of work's been done to get us ready to go do these EVAs. Installing these lithium-ion batteries, very, very important for the program. It's a nice step up from a technology standpoint. It gives us a little longer life on the batteries going forward. We can get them to orbit with a lot less volume and mass, and so again, just a lot of upside to us stepping up to this technology. So we're looking forward to completing the installation with these EVAs. We at this morning's mission management team meeting, we did our standard EVA readiness review, and coming out of that review, certainly the suits are ready. I feel like the team is certainly ready, and the ISS is in the right configuration. So the entire partnership was go, and we're ready to go do this EVA. So with that, I'll let Judd talk to you a little bit about the specifics.
Thanks, Kenny. Let's see, the spacewalkers for US Spacewalk 38 will be NASA astronauts Shane Kimbrough and Peggy Whitson. They're scheduled to egress the Quest airlock Friday, January 6th, starting at 6:10 local time central. This will be Shane's third spacewalk and Peggy's 7th spacewalk. Assisting them will be European Space Agency astronaut Thomas Pesquet and Russian cosmonaut Oleg Novinsky. They'll be helping Shane and Peggy suit up prior to their egress. As Kenny mentioned, the major objective of this spacewalk is to complete the replacement of the nickel hydrogen batteries that are currently on board the station with lithium-ion batteries on the 3 alpha power channel. And that replacement started New Year's Eve, December 31st. So 6 batteries, 6 lithium-ion batteries, and 6 adapter plates were brought up on the Japanese Space Agency cargo vehicle, the Kanatori 6, or HTV-6, that arrived on station December 13th. I think we have a video that kind of shows the robotics operations, what's been happening, just a taste of that video. There we go. So this just gives you an idea. This is the dexterous manipulator that's going into the external pallet that was delivered on Kanatori 6, grabbing one of the lithium-ion batteries with its arm 2, and then maneuvering over to the IEA for the 3 alpha power channel. It's going to install it to a slot that was previously left open in place, and then it'll go over and grab another battery that's one of the nickel hydrogen batteries, take that out from the IEA, and then replace that, put it on the external pallet that was brought up by HTV-6. Each of the 8 power channels that the station has contain 3 strings of batteries. Each battery string contains 2 nickel hydrogen battery units in series, and each of those 2 nickel hydrogen batteries pairs will be replaced by 1 lithium-ion battery and 1 adapter plate to complete the power circuit. There's a data link cable between the adapter plate and the lithium-ion battery, and that provides additional battery parameter insight. And the top of the adapter plate can be used as a storage spot for an old depleted nickel hydrogen battery. Let's see, so with that, I'll hand it over to Gary Horlocker, who is the lead flight director for US Spacewalk 39.
Okay, thank you, Judd. Good afternoon, everybody. Once EVA-1 is complete, the flight control team will go ahead and power up those new batteries, verify everything looks good, and then configure Channel 3A back to a nominal configuration where it's supporting its own loads again. At that point, the team will shift its focus over to the 1A channel We have about a week's worth of work to get it prepared to send our guys out for the EVA number 2. So starting Saturday afternoon, the robotics team will do a couple get-ahead activities while we wait for those 1A batteries to drain off and be in a good configuration to start the robotics. They'll go ahead and release one of the 2 bolts on each of the lithium-ion batteries on the EP, and that'll get them ahead for a couple days down the road when they're about to go transition those batteries from the EP over to the new channel. Sunday afternoon, the 1A old batteries should be all drained off and be in a good configuration for the main robotics to begin. And that team will take about 4 to 5 days to remove 5 of the old batteries from the 1A channel and install the 3 new lithium-ion batteries into that channel. And once that's complete, we'll be in a good configuration to send our spacewalkers out the door next Friday to go ahead and do spacewalk number 2. For that spacewalk, Shane will be EV1, and that'll be his 4th spacewalk, and Tomas will be EV2, and that'll be his 1st spacewalk. And again, inside we'll have Peggy and Oleg helping out with both the suit up before the EVA as well as the D-suit after the EVA. The main objectives of EVA2 are the same as EVA1. Effectively, the crew's going to go out, install the 3 adapter plates into the 1A channel, and again, we're only leaving 1 old battery behind on this channel, so they'll relocate that old battery on top of one of the new adapter plates. And once those tasks are complete, the main objectives will be complete. And as always, if we have extra time, we'll go look at some of our get-ahead tasks that we have in our job jar. After the EVA, we'll basically do the same thing. Flight control team will go ahead and activate those batteries, check them out, make sure everything looks good, and then return channel 1A back to a normal configuration. At that point, there's still a little bit more robotic work to do. We'll have 3 old batteries on the SPDM being held. They were waiting for the adapter plates to be removed from the EP, so now there's a home to put those in for disposal. And so the team will go ahead and take a couple days to install those into the EP, and that'll put the EP in a good configuration to be installed back into HTV for its release later in January. And so with that, I'll hand it over to Keith and give you some more details about the spacewalks.
Okay, thank you, Gary. So this is US EVA 38 and 39. It's the 196th and 197th Space Station Assembly and Maintenance EVA for the US team. Let's see, we spent a lot of time in preparation for this EVA working with the robotics team. We went through all the nominal scenarios and all the backup scenarios, and we came up with quite a list of failure trees to address should the robotics have any problems. And the good news is that we got to this point today with just 1 single bolt that's outside the nominal, and we're preparing to add that into our timeline to fix. But let's see, I'd like to roll my first video. It's EVA 1. Shane Kimbrough is EV1, as we talked about. He'll have the red stripes. He comes out first. Peggy will hand him a crew lock bag, and then she'll come out with him with her own crew lock bag. Shane will start translating up our translation path that we call the CETA spur up to face 1 of the truss, and then translate out to the crew and equipment translation aid, the CETA cart, where he'll take his crew lock bag, attach it to an articulating portable foot restraint, and he'll take that whole bundle and he'll put it on his body restraint tether. He'll translate farther out along the S1 truss, and he'll change over to his 2nd safety tether and continue out to the S4 truss, which is where we'll start our adapter plate installation. While he's doing that, Peggy will be translating from the airlock and following him along the same translation path. She'll be going up the CETA spur to face 1. From there, she continues all the way down to the end of S1 and hooks up to her 2nd safety tether and heads back up to the exposed pallet. Once she's up there, she takes her crew lock bag. This contains all the tools she'll need to get the adapter plates ready for removal. She temporarily stows it on a set of handrails. She'll take out a ratchet wrench, and the first thing she does is she releases the torque on the adapter plates with a ratchet wrench. And she'll work her way around and release all of the bolts on the 3 adapter plates. In this video, you can see the 3 old nickel hydrogen batteries to Peggy's left in the view. Those are stored for return. Meanwhile, back on the integrated equipment assembly, Shane will be taking his articulating portable foot restraint, putting it in position where he'll use it. He'll take the crew lock bag off and position it. This has the tools in it that are needed for installation of the adapter plates on the integrated equipment assembly. When Shane's done with that, well, he'll install some what we call scoops. They're ORU handling devices. That's the first battery we'll move. From there, he'll go up to the exposed pallet with Peggy, and the 2 of them will release the first adapter plate. They'll put it on their body restraint tether. They'll release the second adapter plate. Shane has that on his body restraint tether. And then the 2 of them will make their way back out to the integrated equipment assembly. Once they're at the work site, Shane will ingress the foot restraint. And Peggy will hand him the first adapter plate. He'll drive 2 bolts to install that. Then we have the data link cable that the 2 of them will work together to attach the first lithium-ion battery to an adapter plate. Once that's done, it gives us an opportunity to start the checkout process on that battery set. Shane egresses, repositions his articulating portable foot restraint, gets ready to release the first nickel hydrogen battery. Once that's released, he takes it out and he hands it to Peggy. She holds on to it, maintains control of it. Shane repositions his articulating portable foot restraint back over the adapter plate. And once he's there, Peggy hands him the battery. And he puts it in position on top of the adapter plate. From there, Shane repositions, takes his adapter plate, and installs it on the IEA. Once his 2 bolts are driven, he releases the data link cable, and he and Peggy attach it to that lithium-ion battery. At that point, we have 2 good battery sets, and the channel is operable at that point, but we continue on. They release the last nickel hydrogen battery on this channel. Shane hands it up to Peggy. Then he repositions the articulating portable foot restraint. Peggy hands it back to him. And he installs it. From there, the 2 crew members make their way back up to the exposed pallet, and they retrieve the last adapter plate for the CVA. Peggy cleans up the work site, collects all the tools, puts the crew lock bag onto her body restraint tether, and the two of them return back out to the integrated equipment assembly. Shane installs the last adapter plate. They hook up the data link cable, and we've completed hookup of the batteries on the 3A channel. Peggy starts cleanup. Meanwhile, Shane goes to the other side of the channel, to the 1A side, and he prepares the last bolt to drive on the 1A channel. The robotics did all the rest of them. Once he's released that bolt, they meet back up again, clean up the work site, and they head back to the airlock. Peggy goes in first, followed by Shane. If we have time at the end of the EVA, we'll do some get-aheads, but I'll talk about those in a bit. The second EVA is very similar to the first EVA, with the hopes that the robotics does all of the moves and all of the relocations of batteries. We hope to have 2 open slots instead of 1 open slot the way we did on EVA 38. I have a video that I'd like to roll. Shane comes out first on his 4th EVA. He'll have the red stripes. Thomas Pesquet, this is his first EVA. He'll have the completely white suit. They'll do a buddy check at the airlock. They'll head out the same translation path. Shane will go out to the integrated equipment assembly. He'll do the same articulating portable foot restraint setup, drop off his crew lock bag. You can see that there were 2 open slots there. The arm is full of batteries at that point. Thomas is up at the exposed pallet, releasing the bolts and preparing. They release the 2 adapter plates, and each crew member gets one of the adapter plates. They make their way back out again. And they follow a very similar EVA to EVA 38. They'll install an adapter plate, remove the old last nickel hydrogen battery, and install it on the adapter plate. We'll take the second adapter plate, install it. Then the crew members will make their way back up to the exposed pallet to retrieve the last adapter plate. They'll put it on their body restraint tether. They'll retrieve the tools and the crew lock bag and do an inventory, and then head back out to the integrated equipment assembly. They'll install the last adapter plate, hook up the data link cable, retrieve all the tools and the crew lock bags, retrieve the articulating portable foot restraint. We'll stow that back on the crew equipment translation aid, the CETA cart. And then both crew members will make their way back to the airlock. Thomas will go in first, followed by Shane. And that completes EVA 2. We expect to have more time at the end of EVA 2 to perform the get-ahead tasks that Gary mentioned. We have a list of quite a few tasks that we have available to us in our job jar. To start with, I'll run a video that will show you a cable routing task, and then CETA light retrieval, and then I'll show some graphics after that. Our first get ahead, we send the crew members up to, EV1 will go up to the face 1 of S0. And he's going to climb into the S0 truss. These are the MDM EPIC cables that will be installed on a later EVA. When those MDMs get changed out, we're just pre-positioning them on this EVA. EV2 is going to make their way up to the Z1 element in what we call the rat's nest. And it's called that because of all the jumble of cables that are located in that area. And this is where a previous EVA dropped a bundle of cables and wrapped handrails around. We're going to continue the routing of those cables by taking them off of that location and then translating down with that bundle and passing it inside the truss where the other crew member is waiting. We'll take 2 of the 3 cables and pass them inside. Once those are handed in, the other crew member will take those cables and route them inside to another set of handrails. And this will just make it easier for the EVA where they come out to install these MDMs. They can just reach in and grab these cables. They'll be wire tied to an internal handrail in there. Meanwhile, the last cable will be routed over to another handrail that's in proximity. And that's one of our get-aheads that we have on our list. The next get-ahead that I'll talk, well, let's see, we're also, I guess, cleaning up those cables, routing them out of the way, running wire ties to get them cleaned up. The next task that we have is a 1 crew member task to retrieve the CETA light that's located on the S3 truss. It's internal. It has 2 electrical connectors. One electrical connector and 1 bolt to drive. We'll put that in an ORU bag and bring that back inside. The next get-ahead task that we have on our list is Node 3 shields. We have 2 bundle sets. I've got some pictures that I'd like to show. These are intended to, in an eventual EVA, be placed on the PMA3 or PMA location once that's removed. But they take up a lot of airlock volume, so this EVA is a good opportunity because we're not bringing any hardware out with us or in. So we've taken the time to bundle these up into what you see in the last of the 3 pictures there. We've got tethers wrapped around it, pulling it into a tight bundle. So once it's in the airlock, it takes up a lot of space. So we'd like to get that outside and tethered outside the airlock. Next slide. And this shows the on-orbit video of what the crew put together in this bundle. Next slide. The crew members will hand this out of the airlock, and it'll go just aft and zenith of the airlock hatch on the handrails to be installed. The next pictures that I have are the AMS photo task. The AMS is collecting wonderful science, but its cooling system is having problems. So on a future EVA, crew members plan to go out here and do a pretty intricate repair of the alpha magnetic spectrometer. But in order to do that EVA, we need to collect photos of the external AMS to see some of the work sites and what needs to be done. And we've provided the crew members on board with these images, and they'll go up on the logistics carrier next to the AMS and take these pictures from various angles. So these circles show roughly where we want the crew to take pictures. If you show the next slide. From various angles. So they've been studying this. They know where they want to be positioned on the ELC to take these pictures. Next slide. And so we hope to use these pictures to develop the EVA to repair this. And then one more picture. Some of the cables that they'll be looking for to take pictures. And the last get-ahead task that we have is the crew light pan tilt assembly. This is a failed camera that used to be up on the SSRMS, and the Arm removed that and replaced it on the mobile transporter relay assembly. And so it's pre-positioned there for the crew members to bring out a spare. We'll remove the failed unit off of the MTRA and replace it with the new unit. And then once that's done, the Arm will take that and reinstall it on itself. And that's all I have.
Okay, thank you, Keith. Now, as is tradition, we'll open up the floor for questions. If you're on the phone bridge and you have a question, press *1 to get into the queue. But we'll start here in the room. Gina?
What are the pros and cons to having Dexter do some of this work?
Well, from an overall efficiency standpoint, when we go outside, EVAs are one of the most dangerous things that we do as a program. So anytime we can use station assets that are not the crew to go do a task, then that's certainly something we want to endeavor to do, not just from an efficiency standpoint, but also from a safety standpoint. So clearly, we'd like to continue to learn more and more about how to use Dexter and our robotics capability and make as many of these tasks robotically capable as we can. So it's a big deal for us every time we do one of these, and that team is just continuing to evolve and get better at their tasks. So it's really good.
So you see really a good partnership between what the astronauts can do and then what a robot like Dexter can do and how they can work together?
Absolutely. Again, when you go out EVA, you only have so much time to go out, and we never have enough time to do all the things that we'd like to do. So if we can partner with the robotics capability, I mean, that's the best solution for the entire program. It allows us to do the things with EVAs that we absolutely don't have a choice to do, but our goal would be to whittle down that number of things as we move forward in the program.
This may be a weird question, but what are the advantages to upgrading to the lithium batteries? Durability, length, lightness?
If you look at the batteries themselves, certainly getting to orbit, we're just getting started on changing out these batteries. We've got a lot of batteries on orbit with these different sets of arrays, and the batteries themselves, volume-wise, are smaller. They're lighter mass-wise. A pair of nickel hydrogens are about 730, 740 pounds. One lithium-ion is 430 pounds. So you can almost get a 300 or 400 pound buyback in terms of the mass that you have to launch to orbit. So from that standpoint, it's much better capacity-wise. They're much better batteries. We can go longer. One of the things that gives us fits sometimes is when we have different vehicles arriving to station, we have to lock the sarges and so forth, and we're always worried about battery capacity. This is something that with better capacity, we don't have to do as many power downs, and so operationally it's going to be better off for us too. So from a cost perspective, they're cheaper than the nickel hydrogen when you look at the numbers and the volume of nickel hydrogens that we'd have to buy versus the number of lithium ions. So on the cost front, it's cheaper as well. Also, one of the other things that, as we started down this path of building replacement batteries, one of the things we started looking at was obsolescence. When it comes to nickel hydrogen, we were starting to run into some parts issues on the nickel hydrogen side. So again, it just made all the sense in the world when we went down this path several years ago. And as somebody mentioned in the mission management team this morning, it's nice to see us culminate with finally getting these things on orbit, because they've been in the queue for quite a while.
Mark?
Mark Carruth for Aviation Week. I have two questions. First, as you look ahead, even approximately, how long is it going to take to replace all 48, if I have the number right, of the nickel hydrogen batteries?
We'll be doing this over the next couple of years. We've got another set that we'll have to do at the very end of this year and next year. A large part of this is when can we get them to orbit. So we'll be doing this over the next couple of years, swapping these batteries out, and depending on how these perform these lithium ions, then we'll start to figure out how far these batteries get us in from a life of the program standpoint, and then we can figure out when to put in the next change outs from a lithium ion standpoint. But we'll be looking at nickel hydrogens and swapping those out for the next couple of years.
And just regarding the extension of the station operation itself, the 2020 to 2024 increment that you're preparing for now and everyone's signed off on, how essential to making that successful or effective, efficient operations is it to have these new batteries going into place? And, you know, if you can take it out to the possibility of even going beyond 2024, how important is it to have this new equipment?
Well, it's hugely important for a lot because of the reasons I mentioned earlier, just the ease of getting these to orbit versus getting the others. I mean, that's upmass cost, that's cost avoidance from that standpoint, and as you get deeper into the program, you're looking to reduce costs, you're not trying to increase costs. Also, the longevity, these lithium-ion batteries, if we're looking at maybe 9 to 10 years versus the 6 or so that we look at for the nickel hydrogen, that in and of itself is going to allow us to potentially, reduce cost and make that decision on downstream once we see how they perform on orbit. But we're definitely looking at multiple years of performance beyond what the nickel hydrogens do. So it's a win all the way around.
Okay, it doesn't look like we have any questions on the phone bridge yet. Again, if you're dialed in and you have one, please press *1 to get into the queue. I guess we can go ahead and take a couple of questions from social media real quick. Haley?
Awesome. So just a reminder, keep submitting your questions with the hashtag #AskNASA. We've already got a lot of great ones. Andre on Facebook is wondering, what will happen to the old batteries?
The old batteries, there's part of them will be removed from station on the HTV external pallet. Once the EVAs are completed, we'll robotically take that pallet with some of the old batteries, put it back in the HTV, and when we set the HTV free here at the end of the month, those batteries will go with it. But we'll retain, I believe, 6 of them will remain on station. Is that the right number?
Three.
Oh, 3 total.
So 9 will get disposed of on the pallet with the HTV. When it re-enters the atmosphere, another 3. Again, we just don't have space on the HTV vehicle, so they'll be stored on board permanently.
Paul on Twitter is wondering, how are astronauts chosen for each EVA?
So the chief of the astronaut office primarily makes those decisions in consultation with the lead flight directors, and also there's a panel of EVA instructors and such that all make those decisions.
I think Nicole meant this one more for the astronauts, but I think it applies to mission control as well. On Twitter, she says, I know you have a lot of important tasks to complete, but do you ever have a chance to just enjoy the view?
Well, I certainly, I've got a huge TV in my office, so it's always good to keep it in your mind what we do day in and day out. So some of the views that we get in what we call the 6-pack, which has the 6 different camera views, usually there's 1 or 2 of them trained at the Earth, and again, it's when we got our high definition capability cameras on board here during the last EVA, it's breathtaking to look at that. And again, it certainly makes it a little easier to come in during the day and walk into your office that has no windows when you can look up and see those kinds of views there on the TV. So anyway, I've heard from the crew members on board, there's nothing there's nothing quite like looking at the Earth from their view. Anyway, it's pretty cool for those of us on the ground to get to see it day in and day out from there too.
All right, I think we have one more follow-up in the room, and then we'll be ready to wrap up. Mark?
Yeah, thank you, Mark Carruth for Aviation Week again. How does the choreography, the robotic human choreography that's involved here, sort of compare historically what either other maintenance or other maintenance and construction activities over the life of the program? I think I heard some early comments that, you know, there's a lot of intricate work involved in this, and I'm just looking for a sense of what you guys think is how it rates.
Well, I think through the history of the program, you know, when we started the program, we were already pretty good at EVAs. I mean, the team has learned a lot through the building a space station, but the reality is that the EVA part of things was pretty well understood, and people have continued to fine-tune that. Robotics is an area where, if you look through the history of the program, that team has continued to evolve, just in terms of their knowledge of how to work with the arm. When we got Dexter, again, you know, you had an arm, and then all of a sudden you have a hand and fingers too, and that's pretty incredible. And it's just been a learning process. And again, you know, it's an impressive group, and it's an impressive set of hardware that our Canadian friends have delivered to the program. And again, we want to continue to try to push more and more on the robotics side of things, just because you know, if we're not out doing EVAs, then that keeps crews inside to do science. And so that's what we're trying to push as much as we possibly can. So anyway, I just look for that to continue to grow, and it's something that we've gotten better at over time.
Okay, that's it for here in the room. I think we're going to go ahead and wrap up then. Of course, his first EVA taking place this Friday, so be sure to tune in. Our coverage on NASA TV is going to kick off at 4:30 a.m. Central Time, 5:30 a.m. Eastern. As you heard, they should be getting out of the door shortly after the 6 o'clock hour Central, 7 a.m. Eastern Time. And as always, you can head over to our website at nasa.gov/station for all of the latest updates on these spacewalks and everything else taking place on board the International Space Station. So be sure to tune in this Friday and follow along. Thank you for joining us this afternoon, and thank you to all of my briefers. That'll do it from here at NASA's Johnson Space Center.